Hello everyone, I hope you are good. So today what we are going to do, we are going to understand what is BERT and why it is so famous, and we will also try to understand that what are the things that we need to understand in BERT. So what I will be doing today, I will go in bit detail that what was the requirement that the BERT came into picture, what was before BERT, how the things were getting handled, and why we were adopting strategies that are related to BERT. So this is going to be very interesting kind of series where we will be talking about the topics in bit detail. Okay, so let me quickly give you the understanding that breakthrough. Actually, in 2017 Google released a paper related to BERT. Okay, BERT is nothing but, if we will talk about, I will go to in bit detail, but it's a bidirectional. Bidirectional means in any of the direction, either from left to right or right to left. For example, I give you a sentence that I am a good boy. Okay, so either you can go from I am a good boy, or from the right to left, boy, good, AMI, something like that. So it's a bidirectional one. That is the one thing. Okay, second thing is it's a encoder. We need to understand that when you will pass a text to this model, it will try to give you the vector out of it. Okay, so it's a encoder model, means I can write here like text to vector. It will do vector, you all understand that, right? Then third thing is bidirectional encoder representation of using transformers. Okay, representation, you all know, we are going to represent the text into a kind of vector, and using transformer, this is a very important thing, using transformer. So transformer is an architecture basically where this is based on the self-attention mechanism. We will go in bit detail what is self-attention, why it is so famous, and how the things were working before this self-attention mechanism. We will go to that. But before that, we need to understand that BERT is based on bidirectional encoder representation using transformer, is based on transformers. So first we need to understand what is the big thing about these transformer, why it is getting so much of hype. So for that you have to read a paper called Attention is All You Need. Okay, attention is all you need. From this paper actually we got the concept related to self-attention, and I will go to the detail, but that's what you need to understand. Okay, so now first we need to understand that what are the key challenges that BERT is able to handle. But before going to the BERT, let's try to understand the transformer first. So if I will talk about before transformer, we used to pass sequence to sequence output to these models like RNN and CNN models that we used to have. We used to pass the sequence to sequence data. It means that data will be passed in sequence. For example, like I gave you the example, I am a good boy. So in this case, I will be passed to the model then M will be passed, then A will be passed. So this will be the first one, that will be passed 2, this will be passed 3rd, this will be passed 4th, and last one 5. So sequentially we are passing the data to the model. But with the transformer, the architecture of transformer is such that because of the self-attention mechanism, you don't need to pass the data in sequential format. You can pass the data in any format that you want. Okay, no need to pass data in sequential format. Need to pass data in sequential format. Okay, and as you also know that with RNN we face the problem of that it is not able to capture the relationship in a very lengthy sentences. That's why LSTMs came into the picture. With LSTMs also the same problem arises, but it keeps on happening because it was able to store the hidden information for a lengthy sentence, and because of that some gradient, exploding gradient or vanishing gradient kind of things came into the picture. But let's try to understand that in RNN, in CNN, or in LSTMs, I would say we used to pass the data in sequential format. With the transformer architecture, we don't need to pass the data in sequential format. You can pass it in any of the format. That is one thing. Now the other part is that, okay, what is the big deal then with this transformer will bring to us, right? Now that one thing is clear. Now let's get back to the BERT. So BERT, like I said, it's a bidirectional encoder representations using transformer. So in the back end of the BERT we are using the transformer, where we don't need to pass the data in sequential format, and it's the mechanism of self-attention. Okay, so BERT will be able to handle the data, and it will basically understand the context. Now the next question that arises, that how the BERT is able to understand the context. Okay, let me write it here. How BERT understands the context. Okay, now for understanding that part, as I already explained to you, that BERT is based on the transformer architecture, where we don't need to pass the sequential data. You can pass the data in any of the format. We will talk about that in detail, but let's come back to the BERT. How the BERT model was trained. BERT model was trained using two objectives. One was the MLM, and other one was the next sentence prediction. Okay, next sentence prediction. Now what is this MLM? Let's try to understand this one first. So MLM is basically masked language modeling. Masked language modeling. What is this masked language modeling? It says that, for example, like I gave you the example that I am a good boy. I am a good boy. So what we used to do in masked language modeling, we just try to mask some of the tokens. Okay, so the task here will be that we won't show these mask tokens to the model and using our model, our language model, we will try to predict, okay, if I will give you I, am, a and boy, you have to pass me, or you have to predict what will be the token here in between. Okay, that is the mask language modeling. That's how the BERT model was trained. Next thing is next sentence prediction. Other objective was next sentence prediction. So next sentence prediction means if you will pass a sentence like I am a good boy, but, so it will try to predict what can come after but. Okay, so if I pass a sentence like I am a good boy, but, so it will try to predict this sentence. So this is the other objective that we used to have in training of our BERT model. Now these two things are clear too. Now the third thing is basically why we use BERT. Okay, so because why we use BERT, now this is something very important. Why we use BERT? So because like I said, BERT was trained using two objectives. One was mask language modeling and other one was next sentence predictions. So because of that, it's able to understand the context from the language model, and it's able to solve a lot of NLP related tasks. What are the different NLP related tasks? So let me give you some example. NLP related task, what BERT can help us there. Okay, so for example, you want to do sentiment prediction. Okay, BERT can do that for you. How? You will pass the sentence, it will generate the embeddings, and you will also pass what is the correct label. Okay, and train a classification model. Or if you want your BERT model to predict the sentiment, that also can be done because it understands your data very well. Next task could be next sentence prediction, or question answering. So by using BERT that was trained on Wikipedia data, we were able to solve these problems very easily. So we can say that BERT is a good starting point to solve these problems, and it can be used to lot variety of NLP problems. Okay, so this is the brief intro about BERT, why we use it, what are the difference between a sequence to sequence models versus transformer model, how a BERT is dependent on transformers. So this is all about the BERT. Now in the next section we will try to go deeper and try to understand the architecture of BERT, how it try to understand and what is the self attention, how it try to understand the relations between the different tokens. Okay, so till then, thank you guys, thanks for joining us, and please subscribe the channel if you haven't done that. That will encourage us to do good work. Thank you.